So today's lesson, we are going to talk about basic counting principles. It's not quite as easy as one, two, three, but it is pretty close. We are going to focus on the multiplication rule and the addition rule today. You might want a calculator just for some of the larger numbers, but most of this you can do mentally and figure out your answers, okay? So first of all, the multiplication rule tells us that we need to multiply the different possible choices to get the total possible combinations. So we're going to be looking for combinations of things here, and we're going to take all of the choices together. We're going to multiply them to get the total combinations possible. Let's work through a couple together. So we've got little Dawn here. She has 3 different pairs of pants and 4 different shirts, and we want to know how many different outfits can she make. Now we are going to assume that every shirt can be worn with every pair of pants. And we just want to find different outfits, okay? So what we're going to do is we're going to take the total possible pants that she has, and we're going to take the total shirts that she has, and we're going to multiply them together. So we're going to multiply 3 times 4, and we're going to get 12. So it should be that those are the total possible combinations of outfits that she can make. Now let's break this down a little bit and see if that actually works. So here I have what is called a tree diagram, and I'm matching each pair of pants with the shirts to show the total number of outfits we can make. So if we do gray shirt and green pants, it's 1, purple shirt and green pants is 2, etc. So we've got 4 outfits here, plus another 4 outfits here, plus another 4 outfits here. 4 plus 4 plus 4 gives us a total of 12. So that is, in fact, the correct answer. Now, it's a lot easier to just multiply 3 times 4, right? This tree diagram is not too bad, but let's say we had 15 different pairs of pants and 12 different shirts. That would be a lot harder to draw a tree diagram for just because it's so many different things. So in that case, we could just multiply them together and get the total possible outfits. Let's look at another one. So at Frosty Freeze, everybody's favorite ice cream joint, you can choose either a sugar cone or a waffle cone. So you have 2 choices of cone and 5 different ice cream flavors. They have vanilla, chocolate, strawberry, chocolate twist, and strawberry twist. How many different ice cream combinations can be made? Now, we're going to assume it's just 1 scoop or 1 serving because they have soft serve there. So we're going to multiply the 2 cones by the 5 different ice cream options, and we get a total of 10 different ice cream combinations. Okay? Again, not too terribly difficult. We can figure that out pretty easily. And that kind of makes sense, right? Now, if we think about toppings, let's add in, okay, you can have sprinkles, you can have nuts, you can have, chocolate fudge, caramel, the hard caramel shell. Like there's a bunch of different toppings you can have. Now we would multiply those in as well. Let's say there's 7 different toppings. Now we have 70 different options. So we just keep multiplying the different options together to get the total possible different combinations that we can make. That's the idea of the multiplication rule. So let's say you have a coin, you're going to flip it 3 times. How many possible sequences of heads and tails are there? Well, you have 2 options each time, right? And you're flipping it 3 times. So you have 2 options the first time, times 2 options the second time, times 2 options the third time, and you have 8 total. Now, this one is not too terribly hard. So if we were to make a tree diagram, for your first flip, you could do heads or you could do tails. And then for your second flip, you could do heads or you could get tails, depending on which one you started with first. And then for your third flip, I can't talk. Heads or tails, heads or tails, heads or tails. See how it kind of looks like a factor tree, right? Same idea. And we have a total of 1, 2, 3, 4, 5, 6, 7, 8 different possibilities. So maybe you get, tails, 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 or you get tails, heads, and then tails. There's 8 different possible combinations or sequences that you could get. That's where the 2 times 2 times 2 comes into play. Okay? Let's talk about this a little bit more. So you're looking at a password. And remember, when you have to change your password, they give you all these, ramifications, like it has to be so many characters long, and it has to include a number, and it has to include a special character, et cetera, et cetera, et cetera. And it's case sensitive, the whole thing. So we're going to kind of play with this a little bit and see how many different possible combinations of passwords you can make. Now, we are going to assume that a password is not necessarily a word, right? Because sometimes your passwords are just a string of letters together with an exclamation point at the end or whatever. So we're just going to assume that we're using some combination of letters and numbers to create a password that is not necessarily a true word. Now, it has to be exactly 8 characters long in this case, and you can only use letters, upper and lowercase, and numbers. So no special characters for this one. But an uppercase A is different than a lowercase a, right? So let's think about how many possibilities we have. So we have 8 different characters we have to come up with. 1, 2, 3, 4, 5, 6, 7, 8. Okay? For the first position or the first character, you have the option of an uppercase letter, a lowercase letter, or a number. So how many letters do we have? We have 26 letters in the alphabet, uppercase, 26 lowercase, and we have 10 digits, right? 0 through 9. So you have a total of 62 options for that first character, 26 plus 26 plus 10. Now, it doesn't say anything about repetition, so it seems like you can just, you could do A if you wanted to, which means that you have 62 options for all of these. So for all 8 characters of your password, you have 62 options. To find the total number of combinations, we're going to multiply those 62s together. Or in this case, since they're all the same, it would be 62 to the 8th power. We'll punch that in your calculator. This one we can't do mentally. And we get 2.183, etc., times 10 to the 14th. So that is a huge number of possibilities for a password. That's why it can be so, why they have to run these computer programs and whatever. If you're trying to break someone's password, it's difficult. Now, if we were to limit that to actual words, that takes it down a lot, because depending on what your first letter is, you can only make so many words. It's still a lot of different combinations, but using just plain characters, you have so many combinations, 2.18 times 10 to the 14th power combinations. Okay, so that's a lot. Okay, we're back to Dawn here. She this time has 3 different pairs of pants and 4 shirts, and we're going to add in 2 pairs of shorts for her bottoms. Now, Dawn's mom is a little strict, and she says, Dawn, you cannot wear pants and shorts at the same time. So you have to choose a bottom. So how many different outfits can she wear? Well, this time she has 3 pants and 2 shorts, so she has 5 choices for what she's going to wear on bottom, right? Times the 4 shirts that we saw earlier. This time she has 20 different outfit combinations that she can make, okay? So there's no reason for Dawn to be saying she doesn't have anything to put on in the morning, because she has 20 different possible combinations that she could put together for outfits. Hopefully the multiplication rule is kind of making sense for you. It really is pretty straightforward. You're just multiplying the different combinations. And to be honest, a lot of this is common sense. If you just kind of think about it, it makes sense that you would multiply the pants and shorts times the tops and get the total number of outfits. The addition rule is very similar in that if there are 2 ways of doing something, you add them together to get the possible combinations. This one is probably even more, it makes more sense, just because if you kind of think about it. For example, here's a situation. You're at your cousin's wedding, and you can choose an entree that's either fish or beef. There's 2 different kinds of fish and 3 different kinds of beef. How many meal options do you have? 5, right? That just kind of makes sense. You have 2 different fishes, 3 different beefs. You have 5 different meal options, and you're going to pick one. So the addition rule is really not very difficult. It kind of makes sense in your head, but we wanted to define it out because there is an actual rule to this, okay? So let's say you win the Friday drawing for Student of the Week, and you get a prize, and you can choose either a $25 restaurant card or gas gift card. Your restaurant choices are given here below, and we have 6 different restaurant options, and your gas station choices are Quick Trip, BP, or Mobile, so 3. How many choices do you have? 9, right? 6 plus 3 is 9. That just kind of makes sense. Not too terribly difficult with the math here, okay? It just kind of makes sense that you can pick from those 9 and you have 9 different options. Which one would you pick? Now that's a more intense conversation, right? Are you going to go with gas or are you going to go with a restaurant? Gas seems the more sensible choice just because gas is expensive and who wants to pay for it, but it'd be nice to go out for dinner too. Kind of think about that one. What choice would you make if you had this choice? And follow-up question, should we start doing this for Student of the Week? That'd be kind of nice, wouldn't it? Sometimes we're going to combine these. So sometimes we're going to use the multiplication and the addition rule, kind of like we did with Dawn's pants, to be honest, and put them together, okay? So let's talk through this. So we're back to the password idea. Your password has to be at least 6 characters long, but no more than 8. You can use only lowercase letters and numbers. How many different passwords can you create? So you have a couple options here, right? Your password could be 6 characters long. 1, 2, 3, 4, 5, 6. Your password could be 7 characters long. Or your password could be 8 characters long. Now, how many options do you have for each character? It's only lowercase letters, which is 26, and numbers, which is 10. So you have 36 options, right? And that's true for every single blank here, so 36 to the 6th. And same on the 7 one, you can choose 7, but you still have 36 options for each of these, which gives you 36 to the 7th. And then, of course, for the 8th, you have 36 to the 8th. Then, to find out the total, we're just going to add these together, okay? So you're going to add 36 to the 6th plus 36 to the 7th plus 36 to the 8th. So go ahead and punch that in your calculator because nobody expects you to do this mentally. And you get, what, 2.9016. And that is times 10 to the 12th. Okay? So you still have a lot of different combinations depending on whether you go with that 6, 7, or 8 character password. Not quite as many as the last one, but pretty close, okay? So hopefully you're feeling confident about using the multiplication rule and the addition rule. Again, it's kind of common sense, but it helps to kind of list out your different options and then multiply them all together. So go ahead and work on your assignment on this. Hopefully this is making sense for you, and we will continue with more probability and statistics stuff tomorrow.